Okay, so now we'll see that how this list of 7 fundamental physical quantities is going to help us understand the other derived physical quantities. Okay, fine. So let's say take the example of speed. Okay, speed, let's say we know what is speed, right? How fast something is moving, speed. So speed is what length something has traveled in what time interval, that is speed. Okay, so that is length, what length in what time interval, so that is length upon time, isn't it? So there is one thing called dimensional formula. Okay, dimensional formula of a physical quantity that helps us understand that what is the relation of that physical quantity with these fundamental physical quantities, for example. And the dimensional formula is denoted by this rectangular bracket like this. Okay, so the dimensional formula for speed will become, this is L by T. So I'll write this is LT minus 1. Correct? So now I know that okay, speed is made up of length and time, and that is the relationship LT minus 1. Okay, let's take another one. Let's take another one. Okay, let's say acceleration. Okay, there's one more thing. Okay, so dimension. What is the dimension of the 7 fundamental physical quantities? Themselves only, they are the fundamental. So for the dimension of length is L, times T, temperature K, mass capital M, like that. Okay, so we are not worried about that, but anything else. Okay, so there is one thing we have to understand now, that what is the dimension of change of something. First understand change, I'll denote by this delta sign. Okay, so if I say change of, change, delta means change of velocity. Velocity, speed is the magnitude, the quantity of velocity. There is a difference in speed and velocity, what exactly we'll be seeing in the next chapter. But for now, magnitude wise they are the same thing. Okay, magnitude of velocity is speed. Okay, so direction is what makes them different. We'll see that in the next chapter, not a problem. So the change of speed, what is the dimension of this? The dimension of speed we see is LT minus 1. Okay, LT minus 1. Okay, so the units also come from here only, LT minus 1. Now if I wish to write the SI unit of speed, what will I do? I know that it is composed of length and time. Okay, what is the SI unit of length? Meter, right? So the unit for speed will become meter m, small m, it is denoted by. Okay, and time is seconds, ms minus 1, meter per second becomes the SI unit of speed, right? Similarly we can write the CGS unit of speed. What can be the CGS system unit of speed? CGS, I told you, in CGS system what they take, for meter they take centimeter instead, for length they take centimeter instead of meter. So this L is the same. L, for L take centimeter instead. If you have to write the CGS, this was what? This was SI system, right? SI unit. This one, meter per second. This one will become centimeter per second. Simple. That is in CGS system, isn't it? FPS will become feet per second. Feet per second will become for FPS. So like this we can write the unit of any physical quantity if we have the dimensional formula correct. That is one thing we can write. Now what is the dimension? I told you that the dimension of speed is LT minus 1. What is the dimension of change of speed? Change of speed. Okay, so if I ask you that something was moving at a speed of 2 meter per second, and then the speed increased to 5 meter per second. Okay, there has been a change of speed. Then what is that change? That change is of 3 what? 3 meter per second only, right? Meter per second only. So the change also has the same dimension, same unit, right? Sorry, the change also has the same dimension. So whatever the dimension is of speed, the same is the dimension of change of speed. Okay, same goes for any physical quantity. Whatever is the dimension of force, change of force will have the same dimension. Correct? I explained this using this example. Okay, so that is it. Speed lt minus 1. Okay, let's try to write the dimension formula for some other thing. Okay, so what is the dimension formula for change of speed? Delta s, if I say, or delta v, change of speed. Let's say change of speed, the dimensional formula is lt minus 1 only, right? Correct. Okay, let's try to write the dimensional formula for acceleration. Acceleration. Now acceleration, we know, is the rate of change of speed with respect to time. Okay, that means in this chapter you will be given the formula. Okay, you don't have to worry about the formula because this is just the first chapter. Okay, as we proceed with the chapters, you will be knowing all the formula where they are coming from. Okay, so but this first chapter you will be given the formula, you just have to find the dimension and the units and these things, the basic understanding thing we have to do in this chapter. Okay, so acceleration, I told you, is the change of speed in some given time interval, what has been the change of speed. Okay, now if someone says ki what is the acceleration's dimensional formula, that is what, that is the dimensional formula of change of speed upon this thing. Okay, so delta v, the dimensional formula I told you, is the same as the dimensional formula for speed, right? And this is delta t, same as the dimensional formula for time. Time is a fundamental physical quantity, you don't have to worry about that. Okay, so this is equal to v, the for velocity, the speed, it is lt minus 1. For speed it is lt minus 1, we just saw, right? And upon time is t. Correct? So this becomes what? lt minus 2. So lt minus 2 is the dimensional formula for acceleration, right? Now if someone says ki what is the SI unit of acceleration, easy. What is the, I know the dimension formula, lt minus 2, right? Now what is the, for L, SI unit is meter, for time it is seconds. So I'll simply write the SI unit for acceleration will become then what? Meter per second to the power minus 2, or meter per second square becomes the SI unit of acceleration. Correct? Now what is the dimensional formula for force? Force, as given by Newton, is equal to mass into acceleration. As I told you, the formula will be given. So force is equal to mass times the acceleration. This is the formula. Okay. Now, if you have to write the dimensional formula of force, what you'll do? This is mass into acceleration. So the dimensional formula of mass into the dimensional formula of acceleration. Mass is m only, right? That is standard. Acceleration we just found out, sorry, found out. Acceleration we just found out, lt minus 2. So lt minus 2. Okay, so m lt minus 2 becomes the dimensional formula of force. Correct? Now someone says ki what is the unit, SI unit of force? Not a problem, we know what is the SI unit of this m, mass. Mass, it is kg, we know. Dot L, it is meter, we know. Time, it is second, we know. Kg meter per second square. Kg meter per second square, kg meter s to the power minus 2 is the unit of force, is the SI unit of force. Correct? If you need the Cgs unit, put for m, for capital M you put gram, for L you put centimeter, time you put second only. That will give you the Cgs unit of force. Okay, fine. Now kg meter per second square, this thing only. So 1 kg meter per second square only we have given a special name. Okay, 1 kg meter per second square 1. Okay, this is unit. Okay, So unit of force, like 1 kg is some amount that you see, the weight that we use in market to measure. So 5 times of that is 5 kg, 10 times of that is 10 kg, right? So similarly, this is a unit, this much is 1 unit of force. Okay, this has been given a special name to honor Newton, correct? So this 1 kg meter per second square has been given a special name called 1 Newton. Okay, 1 Newton, special name just. Okay, fine. So that every time you don't have to say, and to honor obviously Newton. Fine. Now if someone says what is the Cgs unit, easy, we can find out. Cgs unit will be, we know the dimensional formula. The dimensional formula is for the physical quantity mlt minus 2, right? So I told you, for mass I'll take gram. Okay, for length I will take centimeter, time is second for Cgs also. So this is okay, this also has a special name. Okay, 1 gram centimeter per second square also has been given a special name. This is called 1 dyne. This is called 1 dyne. Okay, so this is the Cgs system. This becomes the Cgs unit of force. Newton or 1 kg meter per second square becomes the SI unit of force. Fine, easy, nothing to be confused about, right? Okay, can we do a conversion? Can we do a conversion between the unit system? Can we say that how many, actually ultimately they are force only, right? So if someone says in dyne 10 dyne, so then someone might be wondering that okay, in newtons how much it is. Easily we can convert here only, right? Let's try to find out how many dynes is equal to 1 newton. Okay, so kg, this is 1 newton. 1 newton is what? 1 kg into 1 meter upon 1 second the whole square, right? So this only, if you write here, just see, if you just write it here like this, for 1 kg I will write what in grams. If I have to express, 10 to the power 3 grams, isn't it, into 1 meter. This is 1 meter, 1 kg into 1 meter upon 1 second whole square, that is right. So this is okay, I'll just write this 1 kg. For 1 meter I'll write 10 square centimeter, 100 centimeter, and upon that is 1 second square or second square only, simple, second square, 1 second square, second square, right? So this becomes what? 10 to the power 5 gram centimeter s to the power minus 2. Now this is what? This is dyne. This is, so 10 to the power 5 dyne is equal to 1 Newton. I can say from here easily. So I can easily conclude that 10 to the power 5 dynes is equal to 1 Newton worth of force. This is how we can interconvert between units. Okay, and we can, using the dimensional formula, we can write the unit of any physical quantity. How to write the dimensional formula? You should be knowing the relationship, like we knew here, force is equal to mass into acceleration. So how the units are related, how the physical quantities are related, that is what we have to study. Ultimately we have to study that. Fine, and if you know that relationship, you can write the dimension formula, you can write the units. Okay, and then here what we saw, that for a physical quantity, whatever is the dimension formula, the change of that physical quantities has the same dimensional formula that we have seen. Okay, and the seven fundamental physical quantities, the different the SI standard system, SI system that we'll be using mostly, but CGS, FPS, other systems are also there. Okay, okay, fine.